Hey viewers, welcome to the Skull Creation. Today I brought new short video lecture of chapter Acid Bases and Salt of class 10. I will tell you all the detail of this chapter step by step, so kindly watch till end. Properties of acids. Produce hydrogen ions H+ in H2O. Sour taste. Turn blue litmus red. Act as electrolytes in solution. Neutralize solutions carrying hydroxide ions. React with several metals releasing hydrogen gas. React with carbonates releasing CO2, Destroy body tissues. Corrode metal surface quickly. On the basis of origin, acids are classified as A. Organic acids, acids derived from living organisms like plants and animals. For example, citric acid is present in fruits, acetic acid present in vinegar, oxalic acid present in tomato, tartaric acid present in tamarind, lactic acid present in sour milk and curd. B. Mineral acids, they are also called inorganic acids. They are dangerous. Example: sulfuric acid, H2SO4, hydrochloric acid, HCl, etc. On the basis of their strength, acids are classified as A. Strong acids, completely dissociate into its ions in aqueous solutions. Example: nitric acid, HNO3, sulfuric acid, H2SO4, hydrochloric acid, HCl. B. Weak acids, weak acids are those acids which do not completely dissociate into its ions in aqueous solutions. For example, carbonic acid, H2CO, acetic acid, CH3COOH. On the basis of their concentration, acids are classified as A. Dilute acids, have a low concentration of acids in aqueous solutions. B. Concentrated acids, have a high concentration of acids in aqueous solutions. On the basis of number of hydrogen ion, acids can be classified as Monoprotic acids. Such type of acid produces 1 mole of H and ions per mole of acid, example HCl, HNO3. Diprotic acid, they can produce 2 moles of H and ions per mole of acid, example H2SO4. Triprotic acid, they produce 3 moles of H and ions per mole of acid, example H3PO4. Polyprotic, they can produce more than 3 H and ions per mole of acid. Properties of base. Produce hydroxide ions O in H2O. Water-soluble bases are called alkalis. Bitter taste. Turn red litmus blue. Act as electrolytes in solution. Neutralize solutions containing H and ions. Have a slippery, soapy feel. Dissolve fatty material. On the basis of their strength, bases are classified as A. Strong bases. Strong bases are those bases which completely dissociate into its ions in aqueous solutions. Example: sodium hydroxide, NaOH, potassium hydroxide, KOH. B. Weak bases. Weak bases are those bases which do not completely dissociate into its ions in aqueous solutions. For example, ammonium hydroxide, NH4O. On the basis of their concentration, bases are classified as A. Dilute bases, have a low concentration of alkali in aqueous solutions. B. Concentrated bases, have a high concentration of alkali in aqueous solutions. Strength of acid or base solutions. A scale for measuring hydrogen ion concentration in a solution, called pH scale, has been developed. The P in pH stands for potens in German, meaning power. P equals potential or power, H equals hydrogen. pH sensitivity of plants and animals. Human body works in a narrow range of pH 7 to 7.8. Acidity can be lethal for plants and animals. pH of digestive system, stomach secretes HCl to kill bacteria in the food. The inner lining of stomach protects vital cells from this acidic pH. pH and tooth decay. Lower pH because of sour food and sweet food can cause tooth decay. The pH of mouth should always be more than 5.5. pH as self-defense mechanism in plants and animals. Certain animals like bee and plants like nettle secrete highly acidic substance for self-defense. Properties of salts. Salts form by the combination of acid and base through neutralization reaction. The acidic and basic nature of salts depends on the acid and base combined in neutralization reaction. Properties of salts. The most common salt is sodium chloride or table salt, which forms by the combination of sodium hydroxide, base, and hydrochloric acid. Other examples include Epsom salts, MgSO4, used in bath salts, ammonium nitrate, NH4NO3, used as fertilizer, and baking soda, NaHCO3, used in cooking. The pH of salt solution depends on the strength of acids and base combined in neutralization reaction. Indicators. Indicators are substances which indicate the acidic or basic nature of the solution by their color change. Chemical properties of acids. Acids react with active metals to give hydrogen gas. Zn and H2SO3, ZnSO4 plus H2. 2. Acids react with metal carbonate and metal hydrogen carbonate to give carbon dioxide. NaHCO3 plus HCl, NaCl and H2O and CO2. 3. Acids react with bases to give salt and water. This reaction is called as neutralization reaction. NaOH and HCl, NaCl and H2O. 4. Acids react with metals oxides to give salt and water. CuO and H2SO4, CuSO4 plus H2O. Addition of acids or bases to water. The process of dissolving an acid, especially nitric acid or sulfuric acid or a base in water, is a highly exothermic one. As a rule, always add acid to water and never the other way. The acid must be added slowly to water with constant stirring. If one mixes the other way by adding water to a concentrated acid, the heat generated causes the mixture to splash out and cause burns. Chemical properties of bases. Reaction with metals. Certain reactive metals such as zinc, aluminium, and tin react with alkali solutions on heating and hydrogen gas is evolved. 2 NaOH and Zn, Na2ZnO2 plus H2. 2. Reaction with acids. Bases react with acids to form salt and water. KOH and HCl, KCl and H2O. 3. Reaction with non-metallic oxides. These oxides are generally acidic in nature. They react with bases to form salt and water. 2 NaOH and CO2, Na2CO3 plus H2O.